Hello everyone, welcome to the session for using Redis to improve your web application performance. A quick introduction. Mark, do you want to go ahead?
Okay. Hi, so yeah, I'm Mark. I'm a principal software engineer in the distributed systems team working on tools like ASP.NET, and in particular at the moment I'm looking at caching using Redis, and I'm also a maintainer of the stackexchange.redis library.
And hello everyone, my name is Catherine. I'm a senior product manager in Azure Cache for Redis team. So today we will have a quick look at what is Redis Cache and what are the scenarios using Redis Cache in your application. Then we will have some demos for the scenarios. So what is Redis Cache? Mark, you are the expert here.
Yeah, sure. So we all know that cache of various kinds is an important tool for improving the performance of pretty much any kind of application. But some systems, for example, web server applications, have some additional constraints, especially if we're thinking about an in-process cache in our system. So, for example, you might have many nodes or server processes in your system, which means that you can get issues with cache consistency if you're using an in-process cache, where different processes, kind of different nodes, have different versions of the same cache value, and that can cause kind of problems with people seeing different values at different times. But also in web applications, the processes might be short-lived, especially if we think about serverless applications, which means that our in-process cache might never actually get kind of properly populated. As soon as it starts to become useful, that process is going to die, and that can, regardless of how old that data is, and that can cause additional problems. And finally, when we talk about caching, the data we might want to cache might be larger than the memory we want to kind of scale into all of our multiple instances or server instances. And that becomes an increasing problem if we have lots of application nodes. So by moving the data out of process into a dedicated cache system, we can solve all of these problems. And Redis is one system that works very well as an out of process cache, among other things. It's a well-established and trusted tool that provides high performance, flexibility, and reliability.
Yeah, exactly. So especially if my application runs in a cloud environment, I want it to be scalable and I want to avoid configuring client session affinity. So if you happen to host your application in cloud, such as in Azure, luckily we have the first party offering Azure Cache for Redis. It's a joint partnership with the Redis company. If you go to Azure portal, create a resource, and search for Azure Cache for Redis, you will see both the enterprise and the open source offerings. So since Redis is a very great product, but what can we actually do in our web application, Mark?
Right. So you can use Redis in a huge number of ways, but there are a few that are used a lot of the time, and most of those are available right out of the box. So going through the numbers on the slide here, one important way of caching is to use output cache. So that's where we want to reuse the entire HTTP response between compatible requests, which usually means anonymous requests where we're just doing kind of simple gets on data. But if we can reuse the entirety of an HTTP response, that means we're avoiding all of the work that went into building a page, all of the external resources, databases, web queries, all sorts of things, and we can reuse all of that work across a large number of requests. So that's one way of kind of using Redis that we can do now. But for even if we can't reuse the entirety of a page, we might still want to reuse some parts of it. So that's where the distributed cache comes in. So that's number 2 on the slide there. So if we have repeated data queries in a page that we want to reuse, we can still avoid going down to the external resource, whether that's a database, a file system, or some gRPC query, whatever it is. We can still reuse that data, keep that locally in our application, and reuse that in a number of pages as part of building a response, but avoid having to repeat all that work. So that's the distributed cache. And one particular implementation of that is the session store. So that's where we're storing some data, for example, a shopping basket, or it could be information about the logged in user, all sorts of things. Just some basket of data against the current session, the current instance of a connection to the web server, and that is actually implemented on top of the distributed cache system in ASP.NET. So that's a specific instance of our caching. But also, if we're talking about Redis, Redis is much more than a cache system. It is an entire database, not a SQL database. It's a NoSQL database, but it is a rich system with lots and lots of different data types, and we can use those directly to perform specific bits of code. For example, one thing we've got here on the page is a leaderboard. So that's where we've got some type of data with some logical score, whether that could be dates, actual numbers, prices, where we want to order that data and keep track of, how the top values in that value. And Redis can handle that all directly for us. So as long as we're happy to use the Redis API directly, we can use all of that functionality as well.
Yeah, that sounds very useful. So Mark, do I have to be an expert developer to use this in my web application?
Absolutely not. In fact, most of the cases that we've just gone through, we don't need to know anything about Redis at all because they're all kind of baked into the framework itself, into the ASP.NET tools. So Microsoft provide prepackaged implementations of all of those things. So you don't need to know much Redis at all for those, other than to know we want to use Redis and we have an endpoint somewhere that will be provided either internally by your kind of IT support or by your kind of cloud provider, Azure Redis, all of those things. However, if you do want to, if you're using Redis and you want to make the most use of it, for example, to use the advanced native data types in Redis, then learning a bit more about what Redis can do, and because it's especially because it's not the same as an SQL database, learning a bit more about how it does work can only be a good thing. And Redis.io has a full breakdown of all the kind of data types and operations that Redis can perform. And uh, there are a range of client libraries. We tend to use Stack Exchange.redis, or se.redis, as it's also known, as a well-known client library that can talk to Redis. But other client libraries are available. But because of that, you don't need to know much about how to actually talk to Redis. It's all just handled.
Very cool. So it's well supported. So let's take a look into the scenarios in detail. Let's start with the web output cache. So what is output caching? Basically, suppose if a user makes a request to your web application, the web application itself may have to call into dependency resources or APIs, and it may take extra resource on the server to generate the web response before returning the content back to the user. Now, if the user makes the same request with the parameters, there's really no point for the web application to go through all the efforts to generate the same response. So that's where output caching comes in. I can put the response in some cache location, and it will be faster, more performant, and it will save some resources on the server to return the web response. So Mark, I have a question. So why can't I just save all the response in memory in the web server? Why Redis?
This comes down to the things I was describing before. So when we're talking about output cache, we're going to be caching the entire output of an HTTP request. And that can start becoming non-trivial in size. Even a single HTTP response can be pretty big. But when we're caching a number of different requests for some period of time, that can very quickly start to swamp the memory that we want to keep for our server application. But we also have the problem that where people are going to be making repeated requests, it's very easy for them to start seeing different results as they bounce between different web server instances. And we don't want to have to necessarily configure sticky load balancing because that impacts scalability. So by using an outer process cache and moving all of that data into a dedicated store, we can avoid those problems, and we can do all of that using a cache store such as Redis.
So if you host your web application in cloud environment, and if you want it to be scalable in particular, we really recommend a distributed cache like Redis.
Yeah.
So output cache existed since dotnet 7, but we did not have Redis support in it. Now for dotnet 8, we shipped the Redis support with output cache. And Mark, you worked on it. I know you did a lot of optimizations. Do you want to talk about it?
Yeah. So in .NET 7, yes, output cache was provided, but it was only provided as an in-memory, in-process cache. But an extension point was left in place so that people could bring their own backend store using any tool, whether it was SQL or Redis. But Microsoft didn't provide any alternative implementations. We wanted to address that, and in .NET 8, we are now shipping a dedicated Redis output cache implementation. But as part of doing that, we found a number of places in the existing abstraction where the API worked very well for in-process caching, but because of the way the buffer management was working with byte arrays and things like that, it didn't necessarily perform as much as well as we would have hoped when using out of process caching. So we've taken the time to improve that. We've provided a new secondary API that you can implement if you're providing your own output cache implementation. But we've also looked at a lot of the internals of what's going on in terms of how we're storing the data internally, how we're parsing it, and all the transformations that go on under the hood. So all of those things have also been improved and run through various profiling levels. But the good news is that if you have got your existing implementation, we haven't broken any of the APIs. If you just provide an output cache implementation using the API that you had in .NET 7, that will continue to work. You don't need to change anything necessarily. But there is a new API that is available in .NET 8 if you so choose. So that's the kind of the work that we've done for you.
Cool. So basically, if you have something already, there's no breaking changes, everything will keep on working. But if you want to try the new Redis support, we have the optimizations with it. It will work well, and it's really easy to use it.
Exactly.
So let's take a look at an example for using output cache in your web application that calls into Azure OpenAI. The diagram here kind of shows how the application is deployed. It's running in the Azure Container Service, Azure Container Apps, and it will call into Azure OpenAI to generate pictures on demand. It will save the output in Azure Cache for Redis. And here's a sample screenshot for the picture generated. So let's take a closer look into the app. This is my OpenAI art gallery. So without output cache, if I hit the no cache endpoint, and let's just say a purple robot in the sky. Notice it's taking the time to call into Azure OpenAI, and it will take a while for the picture to be generated. Now let's see what we get. Ooh, that's a very cool contemporary robot here. But if I send the same request, let's just say by refreshing the page, it's doing the same work all over again, like calling into OpenAI and another picture is generated. So it's fine if that is the desired behavior, but a lot of times you want your application to be performant, as in getting the response right away, especially if it's repeated requests. In addition, you may want some consistency over the pictures generated. So that's why we can use output cache to improve the performance. Let's call into the cache endpoint. Now let's say a purple robot in the cloud. The first time, it will take the same effort calling into the Azure OpenAI service to generate the picture. Oh, that's cute. And now if I send the same request, let's say by refreshing it, the browser, or like pressing F12, so it's actually sending the request again. Notice it now comes back right away, and it's the same picture. So this will help us improving the performance of the web application, and it also saves me the open API quota. Like I don't have to make as many API requests as I had to before. And how to enable this in your web application? Well, the code is really easy. This is the program.cs file. Firstly, adding output cache only takes a few lines of code. So the first call adds output cache, and then the second one specifies the Stack Exchange Redis implementation for it. And in the route functions, I can either use the chained command to just say dot cache output, or I can use the annotation tag here, and I can pass in options such as the duration for how long the content will be cached. And in some cases, if I want to group the output using a tag and purge the tag, the API is also very easy to support this type of functions. And Mark, I heard like you did something in particular for the purge operation.
Yeah, so one of the tricky parts in cache is cache invalidation. So that's what you want to do when the data is still alive in our cache system. It's still got some time to live, but we want to kind of bin either either individual results or kind of the entire set of data. So the Output Cache API provides a mechanism to do that using tags. And this existed in .NET 7, but this is also something that we've now implemented in the Redis implementation. So you can provide your own tags against any request, either based on hard-coded values or based on something to do with that's coming out of uh, the individual request. It could be kind of, if you think of an eShop, it could be the product category or whether an item is on sale, all of those things. You can store 0, 1, or many tags against that. And then at any point, you can call evict by tag async, passing in the tag that you want to burn, and any requests that have been cached using that tag will be thrown away. Again, this all existed in .NET 7, but this is something that we've implemented specifically in the Redis implementation as well. So you have that full support.
Notice here the evict by tag async. This operation is going to be supported by whatever Mark described earlier. And I mean, on top of all the work we have done, you can just easily call this function and evict a group of output altogether. So like we mentioned earlier, the output cache will return the whole web page content. And in the case if only a partial data can be cached, then we use the distributed cache interface. Somehow, Mark, last time I used the distributed caching, it was really hard. Like I had to do a lot of coding to going back and forth, checking if things are available in cache and do the serializations. So are you doing anything for this?
Yeah. So we briefly mentioned the distributed cache previously, but you're right. There at the moment, the implementation is fairly raw. You need to do a lot of the work yourself. So this isn't something that we're changing in .NET 8, but this is a bit more of a preview. We do have some ideas on this for what we're going to do in .NET 9. So at the moment, if you're using distributed cache, you need to do a lot of work. You need to get hold of invent some string key for your data, probably with the parameters in it. And from there, you need to ask the distributed cache system for the value, which is just going to give you a chunk of bytes. You need to check whether that existed. You need to deserialize the value. If it didn't exist, you need to perform your underlying data query. You need to serialize that value into bytes, store it into the cache. There's a lot of steps there that we don't really want to have to force onto the users. So we're thinking that in .NET 9 we want to simplify this a lot. So we are looking at a range of options at the moment to provide something that's a bit more of a functional API, where you can just pass in a key and some kind of callback mechanism, probably a lambda a lambda expression, to say, if you don't have the value, here's how to go away and get that value for me. and have the system itself deal with all the steps such as serialization, deserialization, while also leaving that kind of configurable, but with sensible defaults. So we'll use kind of system text JSON by default, but have options to use things like protobuf or any other serializer that you want. So we have a kind of a preview API of this that just uses some extension methods and doesn't have all of the functionality, but we want to do a lot more in .NET 9. We want to look at all sorts of things like stampede scenarios with lots of people requesting the data at the same time and dealing with things like all the data expiring at the same time. And also look at some fairly advanced cache invalidation scenarios, maybe using the, particularly in the case of Redis, using the server-assisted caching functionality. So there's a huge loads of things we want to look at there. We have not had time to do them all for .NET 8, but we're working on them. For example, the StackExchange.redis client now also has the ability to use the RESP3 protocol, which means we can look at the server-assisted caching functionality while using half the number of connections. So there's some real functionality changes that we're looking to do that you can't use them yet, but keep an eye on this space, and hopefully this time next year we'll have a lot more to show there.
Cool, I'm excited. So the preview Mark mentioned is available in this blog post. Link is here. You can check out. So ASP.NET Core has a wide range of caching capabilities. Once distributed cache is configured, it's super easy to just add a session store on top of the distributed cache. Let's take a closer look into it. So this is the eShop web app I have. Suppose I'm a customer browsing through the items. Okay, I may want to take a detailed look into this gym bag. And okay, so I'll take a moment to consider. If I go back to the home page, you can see the session data now persists. I just viewed the gym bag from this vendor. If I want to just purchase it, I have a quick shortcut for adding it to my shopping cart. So how to get this type of feature implemented in your web application? In the program.cs code, like we mentioned earlier, it's super simple to add distributed caching and then add a session interface on top of it. And then basically in your controller code, for example, you can just call the session data in the same way, it's the same interface. You don't really have to know about the cache store behind it. And Mark, so we have been looking into the abstractions such as the output caching, the session store, the distributed cache. But what if I want to do something more advanced?
So if you want to do more with Redis, then yes, you need to be able to talk to the Redis server directly. And one way to do that is with the StackExchange.redis library. So that's what we've used in the Microsoft implementations that have wrapped this up when we've been dealing with output cache and distributed cache. And this works with both single server Redis instances and with Redis cluster services. So all we need to do is use the connect method in StackExchange.redis to get hold of a connection to the server. And from there, we can get hold of Redis's iDatabase implementation. And that provides a range of methods that are just grouped by the data type and the operation we want to perform. So if we wanted to deal with Redis strings, which are blobs, or they can be textual or bytes, then we have a range of methods such as string get or string set or async that we can then call to set or fetch those chunks of data from the server, or we can use the Redis lists or geographic queries such as geodistance, geosearch, all of those methods. Basically, the entire set of Redis APIs is exposed directly in the StackExchange.redis library itself. There are too many methods to kind of try and list through here, but all of those are documented on the StackExchange.redis library. And additionally, if you're using your own custom modules in Redis, then you can still issue bespoke queries down to the server Obviously, yes, then you need to deal with the actual kind of Redis protocol a bit more yourself, rather than using the functionality that's baked into the library.
Very cool. So maybe we can take a look at an example for how to use Stack Exchange.Redis directly in your web application. So our example will be a real-time leaderboard. Leaderboard is a very common scenario in a wide range of applications, such as gaming, financial, like you may want to know the top and the bottom movers for the day, support game match, like real-time streaming, you want to know how's the score for each teams are like. This example is written by our colleague David and our business partner from Redis, Roberto, about a real-time leaderboard on the stock market. And here's a full implementation, like an architectural view for everything, like calling into Redis Cache for getting the updated information. And behind it, there's an Azure function that connects the Redis Cache to some persistent backend store like SQL Azure. So all the information is persisted. So just for our convenience here, I made a simpler version of this app so we can zoom into how we use Stack Exchange Redis and how the caching part here works. So this is a game leaderboard application. Basically, I can mimic to be like each player, and once I get a score in the leaderboard homepage, it will display the score real time. Let's say name is Jack and play the game. And now you'll see it appears in the list instantly. Let's say Karen, play game. And noticing how the new player score is already sorted from the largest to smallest. Now, if I go back to my code, I'll show you it's really easy to use it in your web application. Like Mark said earlier, if you use Stack Exchange.Redis directly, you have to establish the connection with the database. And the Redis connection.cs here does that. It establishes the connection resiliently and reliably. This file is available in all the Azure Cache for Redis documentation samples, and you can copy paste to use it. It's very reusable. And to use the sorted set data structure, all it takes is, for example, in my web application logic, I established a connection to Redis Cache. I can just use one of the methods Mark mentioned earlier, like sorted set update async. In this case, I pass in the player information and the score, and then everything will be in the sorted set ranked by the score information. And having said that, yeah, that's all we have for today. So thank you very much. Please try .NET 8, go to this link to download, and here are all the demos and the samples we mentioned earlier.
And if you're using Output Cache, please do try the Output Cache features, especially on Redis, and let us know how you get on.
Cool, thank you.